Space is quiet, vast, and filled with mysteries we are only beginning to understand. As we look up at the night sky, we are not just seeing stars. We are looking into the past. Every point of light has traveled across unimaginable distances to reach us. For thousands of years, humans have wondered what exists beyond our world. Today, we finally have a tool powerful enough to see deeper than ever before. The James Webb Space Telescope, often called JWST, is like a giant eye placed in space. It was built to observe the earliest moments of the universe and to study galaxies that formed billions of years ago. Unlike ordinary telescopes, JWST can detect faint light from very distant places. This allows scientists to study galaxies that existed when the universe was still young. In many ways, it is helping us understand how everything began. Recently, while observing one of these distant galaxies, scientists noticed something unexpected. Hidden within the light coming from far across the universe, they detected molecules that are known as the basic building blocks of life. These include simple organic compounds and elements that, over time, can form more complex structures. What makes this discovery surprising is where it was found. This galaxy existed at a time when the universe was still in its early stages. Scientists believed that galaxies from that period would be too young to contain such complex materials. There simply had not been enough time for many stars to live, die, and spread these elements across space. And yet, the evidence suggests that these life-related molecules were already there. This raises a quiet but powerful question. If the ingredients for life existed so early in the history of the universe, how did they form so quickly? And how did they appear in places where scientists did not expect to find them? As we begin this journey, we will explore what the James Webb Space Telescope is seeing, what these discoveries mean, and how they may change the way we understand the origin of life itself. For now, imagine the universe as it once was, dark, young, and slowly coming to life. Somewhere in that early darkness, the first ingredients were already beginning to gather, long before planets like Earth even existed. And that is where our story begins. If you are enjoying this journey through the universe, take a moment to subscribe to the channel. Liking the video and sharing it with others helps more people discover these calming explorations of space. Your support allows us to continue bringing the mysteries of the cosmos closer to you. The James Webb Space Telescope, or JWST, is the most advanced space observatory ever built. It was designed to help us explore the earliest periods of the universe and to see galaxies that formed billions of years ago. Its instruments are incredibly sensitive, able to detect faint light that has traveled across vast distances and through time itself. JWST was placed far from Earth, beyond the Moon's orbit, where it can remain extremely cold and stable. This allows it to see infrared light, a type of light that is invisible to our eyes, but which carries crucial information about distant galaxies, stars, and the materials that form planets. By capturing this ancient light, JWST is able to look back billions of years. Each image it provides is a glimpse into the early universe. The farther we look, the earlier in time we are seeing. A galaxy that appears small and faint on our screens may have existed when the universe was only a fraction of its current age. Studying these ancient galaxies is important because it tells us how the universe began to form structure. We can see how stars were born, how they evolved, and how they spread the elements necessary for life. In essence, observing distant galaxies is like studying the universe's childhood. When we look into space through JWST, we are not just looking across distance. We are looking back in time. Light from these galaxies has traveled for billions of years before reaching us. Each observation is a snapshot of history, frozen in the light that has finally arrived. Through this telescope, we gain insight into the processes that shaped everything we know, from the stars above us to the very atoms that make up our bodies. The early universe may seem distant and unreachable, but JWST brings it closer, allowing us to understand the beginnings of galaxies, stars, and, ultimately, the ingredients that make life possible. As we continue, we will follow the telescope's gaze to see the building blocks of life forming in galaxies where they were least expected, slowly revealing the universe's hidden story. To understand why this discovery is so remarkable, we need to take a closer look at the basic ingredients that make life possible. At its core, life is built from a few simple elements: carbon, hydrogen, oxygen, and nitrogen. These elements combine in countless ways to form molecules, which can eventually create more complex structures, including those necessary for living organisms. In space, these elements are not scattered randomly. They form clouds of gas and dust, slowly drifting through galaxies. Within these clouds, simple molecules begin to form. Some are tiny, like water molecules made of hydrogen and oxygen. Others are more complex, organic compounds that contain carbon, hydrogen, and oxygen arranged in intricate patterns. Water, one of the most essential components for life, exists in many forms in space. It can be found as ice on dust grains, as vapor in warm clouds, or as frozen layers surrounding newly forming stars. Even in the coldest regions of distant galaxies, water quietly drifts, waiting for the right conditions to participate in chemical reactions. Organic molecules, the building blocks of proteins and other life-essential compounds, have been found floating between the stars. These molecules are small and simple at first, but over time, they can combine and evolve into more complex structures. In a sense, life begins with chemistry. The universe first assembles these small molecules, creating the raw materials needed for everything that comes later. The discovery of these molecules in a distant, ancient galaxy reminds us that life's building blocks are not limited to our solar system. The same basic chemistry that eventually led to life on Earth is present across the cosmos. As we continue, keep this in mind: life begins quietly, with small, simple molecules forming in the darkness of space. Over billions of years, these molecules can come together, forming the foundation for planets, oceans, and, eventually, life itself. It is a slow, gentle process, but one that has been occurring throughout the universe since its earliest moments. As we continue our journey, we arrive at a galaxy unlike any we have seen before. This is a galaxy from the ancient universe, so far away that its light has taken billions of years to reach us. When we observe it through the James Webb Space Telescope, we are seeing it as it existed not long after the Big Bang, when the universe itself was still very young. Galaxies from this time are expected to be simple, small, and relatively empty. The first generations of stars had only just begun to form, and heavy elements, like carbon, oxygen, and nitrogen, were thought to be extremely rare. Scientists had predicted that any galaxy from this period would be dominated by young stars, with little chemical complexity. But JWST revealed something different. Slowly, as the telescope collected light from this distant galaxy, a surprising story began to emerge. Complex molecules, the same building blocks of life we have discussed, were present within the galaxy. Organic compounds, water molecules, and other essential elements had already formed, much earlier than scientists expected. Imagine this for a moment. A galaxy that existed over 13 billion years ago, barely a few 100 million years after the universe began, already containing the ingredients for life. In other words, the universe was creating the potential for life almost immediately after it had started. Scientists studied these findings carefully. They verified the signals, double-checked the data, and confirmed that what they were seeing was real. The molecules were not artifacts or errors. They were genuinely there, floating in the gas and dust between the stars. This discovery challenges our understanding of cosmic history. It suggests that the universe evolved chemically much faster than we had imagined. The formation of life's building blocks does not require billions of years. Instead, it may happen naturally, as soon as stars and galaxies begin to form. It is a quiet, almost poetic realization. Somewhere in this ancient galaxy, the same molecules that make life on Earth possible were drifting silently through space. For billions of years, they have been floating, waiting for the right conditions to take the next steps toward complexity. And yet, the galaxy itself is still young. Its stars are newly born. Its structure is still forming. And already, the ingredients for life are present. Something appeared earlier than expected, hinting that the universe is more efficient, more creative, and more surprising than we could have imagined. As we observe this galaxy, it becomes a reminder of how little we truly know about the universe. Each distant light we see is not just a point of energy, it is a messenger carrying a story from billions of years ago. And in this story, life's building blocks are already quietly playing their part. The galaxy drifts through space, calm and luminous. Its stars shine faintly, casting light across the vast emptiness. Between them, molecules float silently. It is a scene of profound wonder, a glimpse into a universe that has been preparing for life from its earliest moments. And so we continue to watch, slowly, patiently, as the universe reveals its secrets. Each discovery like this brings us closer to understanding our own origins. Even in the vastness of space, in a galaxy that should have been simple and empty, the universe has already begun the quiet work of creation. Something unexpected, something extraordinary, has emerged, long before Earth, long before our sun, long before we were even here to see it. This is the gentle reminder that the cosmos is not static. It is alive in its own way, quietly evolving, quietly forming, and quietly preparing the stage for life wherever it can. And as we leave this galaxy behind, we carry with us a sense of calm wonder. The universe is vast, ancient, and mysterious. Yet even in its earliest moments, it holds the promise of life, patiently waiting to unfold. When we look at the universe, we often assume that things happen in a slow, orderly way. Stars are born, live, and die. Galaxies form, grow, and evolve. Elements are created gradually over millions and billions of years. And life, if it appears at all, takes time. But the discovery in this ancient galaxy challenges that simple picture. The building blocks of life, the molecules we have been following, were found in a place where scientists did not expect them. They should not have existed there yet. To understand why, we need to consider how the universe makes elements. Early in cosmic history, the universe was mostly hydrogen and helium. Heavier elements, like carbon, oxygen, and nitrogen, only form inside stars. Stars fuse these elements during their lifetimes and then release them into space when they die, especially during supernova explosions. Over many generations of stars, these elements spread, creating the material necessary for planets and, eventually, life. Given this timeline, early galaxies, those that formed shortly after the Big Bang, should have been simple. They should have been mostly hydrogen and helium, with very few heavy elements. That is why scientists were surprised. The molecules they found required the presence of these heavier elements. In other words, the galaxy had become chemically enriched far earlier than expected. This raises an important question: how did it happen so quickly? Perhaps the first stars formed faster than we realized. Perhaps they lived short, intense lives, producing heavy elements and scattering them across space. Or maybe the processes that create complex molecules can occur under conditions we are only beginning to understand. Whatever the explanation, one thing is clear: the universe evolved faster than we had imagined. The early cosmos was not a slow, empty void. It was active, dynamic, and capable of producing the ingredients for life almost immediately. Imagine a galaxy forming only a few 100 million years after the Big Bang, and already the raw materials for life are present. Water, carbon-based molecules, and other organics are floating between stars. This is the universe at work in a way that is both efficient and surprisingly rapid. It is a gentle but profound mystery. The molecules themselves are quiet, drifting through space without fanfare. Yet their presence speaks volumes about how early the universe began to prepare for life. This discovery reshapes our understanding of cosmic history. It suggests that life's essential components are not a late addition to the universe, appearing only after billions of years. Instead, they may have been present almost from the beginning, waiting for the right conditions to combine and evolve. As we consider this, we are reminded that the universe is full of surprises. The timeline we thought we understood, the slow, gradual emergence of complexity, may not be as rigid as we imagined. Instead, the cosmos may be more inventive, more capable of creating the conditions for life than we had ever realized. Even now, billions of years later, these molecules continue to drift quietly in the galaxy. They are a reminder that the universe has always been more dynamic, more mysterious, and more capable of wonder than we can easily comprehend. And so, as we leave this galaxy behind, we carry with us the gentle realization that the universe is full of secrets, unfolding in ways that are slow enough for us to observe, yet fast enough to surprise even the most careful scientists. The building blocks of life, appearing earlier than expected, offer a quiet but profound message: the cosmos is always more alive, more creative, and more astonishing than it seems. As we continue our journey through the universe, we turn our attention to the stars. Stars are not just points of light in the night sky. They are cosmic factories, quietly and tirelessly creating the elements that make up everything around us, including ourselves. At first, stars are born from clouds of gas and dust. Gravity slowly pulls this material together until a dense core forms. As the core heats up, nuclear reactions begin. Inside these stellar furnaces, hydrogen atoms fuse to form helium, releasing energy that makes the star shine. This process, called nuclear fusion, powers stars for millions or even billions of years. But the work of a star does not stop at producing helium. Over time, as a star ages, the pressure and temperature in its core increase. Helium fuses into heavier elements, including carbon and oxygen, two of the most important ingredients for life. In massive stars, this process continues, creating nitrogen, magnesium, silicon, and even iron. The universe depends on this slow, steady creation of elements. Without stars, there would be no carbon, no oxygen, no nitrogen, no building blocks for life. Stars are the original chemists, performing reactions that are impossible elsewhere in space. Eventually, stars reach the end of their life cycles. Some shrink into white dwarfs, quietly cooling over billions of years. Others explode in spectacular supernovae, scattering their newly forged elements across the galaxy. These explosions enrich the surrounding gas clouds, spreading carbon, oxygen, and other life-essential materials far and wide. The cycle of birth and death continues. New stars form from the enriched clouds left behind by older generations. Each new generation inherits the chemical legacy of its predecessors. In this way, the universe recycles its materials, gradually building the complex chemistry needed for planets, water, and potentially life. Even in galaxies that formed shortly after the Big Bang, this cycle can happen surprisingly fast. Massive stars live short, brilliant lives, producing and spreading heavy elements within a few million years. This may explain why JWST is finding the ingredients for life in galaxies that are younger than scientists expected. It is a quiet, patient process, unfolding over billions of years. Stars shine, burn, and die, releasing their gifts to the universe. Dust and gas clouds drift in the void, waiting for the next generation of stars to begin the process anew. As we observe this cosmic dance, it is clear that life's ingredients are not random. They are the product of a long, intricate, and beautiful chain of events. The universe prepares these materials quietly, patiently, ensuring that the building blocks for life exist wherever conditions allow. And so, when we look at a star-filled sky, we are not just seeing light. We are witnessing the ongoing work of creation. We are observing the processes that make life possible, scattered across galaxies, drifting through time and space, patiently waiting to become something more. Stars are the universe's ancient chemists. Through their quiet work, they have given birth to the very elements that make life possible. And in understanding this, we begin to see the universe as not just vast and empty, but as a place of infinite potential, always preparing, always creating, and always capable of surprising us. As we continue our journey through the cosmos, we turn our attention to one of the most essential substances for life, water. On Earth, water covers most of the surface, shaping our landscapes and sustaining every living thing. But water is not unique to our planet. In fact, it is one of the most common molecules in the universe. JWST and other telescopes have detected water in the most distant regions of space. Far beyond our solar system, water exists as ice in cold clouds, as vapor near forming stars, and sometimes even as thin layers on dust grains drifting through the void. These clouds of ice and gas slowly move through galaxies, carrying water to new stars and planets. Even in the harshest, coldest corners of the universe, water quietly persists. It clings to particles of dust, gathers in dense molecular clouds, and drifts in space for millions of years. Eventually, some of this water becomes part of new star systems, adding a familiar ingredient to worlds that may one day harbor life. Water is a universal molecule. Its chemical formula, H2O, may seem simple, but its presence is profound. Wherever water exists, there is potential. Potential for chemistry, for complexity, and perhaps, for life. The discovery of water in distant galaxies reminds us that the conditions necessary for life are not confined to Earth. They are spread throughout the cosmos, quietly waiting for the right circumstances to awaken. Consider the journey of a single water molecule. Born in the heart of a cloud, it drifts across space, perhaps frozen for millions of years, until it becomes part of a planet, an ocean, or even the air we breathe. Each molecule carries the story of the universe, a testament to the quiet work of cosmic processes that have been ongoing since the earliest days. And so, as we look at these distant ice clouds and vapor-filled regions, we begin to understand that water is not just a substance. It is a symbol of possibility. It is the thread that connects distant galaxies to our own world. It whispers a promise that life's essential ingredients are far more widespread than we once imagined. Where there is water, there is potential. And across the universe, from the youngest galaxies to the most distant stars, water quietly drifts, waiting for the moments when its presence can spark something extraordinary. As we follow the trail of molecules and water through distant galaxies, a quiet question begins to emerge. If the building blocks of life were already present in the universe so early, could life itself have begun earlier than we once imagined? It is tempting to search for answers, to try to determine exactly when or where life might have first appeared. But the truth is, the universe is patient. It does not rush, and it does not reveal its secrets all at once. Instead, it offers hints, subtle, gentle signs, leaving us to wonder quietly. The presence of water, carbon, oxygen, and nitrogen in galaxies formed only a few 100 million years after the Big Bang suggests that the potential for life has existed for almost the entire history of the cosmos. These molecules drift through space, waiting, interacting, forming, and combining in ways we are only beginning to understand. We do not yet know if these ingredients ever combined to form the first seeds of life in these early galaxies. Perhaps the conditions were not quite right. Perhaps life did emerge, only to vanish again before it could take hold. Or perhaps, in some distant corner of the universe, the earliest forms of life were already stirring, quietly beginning their story. The universe does not answer these questions directly. Instead, it invites us to contemplate, to imagine, and to recognize the quiet possibilities hidden in the stars. We can observe the chemistry, we can trace the molecules, but the emergence of life remains a soft, silent mystery. In considering this, we come to understand something profound. The universe has been preparing for life for billions of years, long before planets like Earth existed. Life, if it emerged, may have started almost immediately once the necessary ingredients were present. The cosmos itself seems to be patient, allowing molecules and elements to combine slowly over vast stretches of time. And yet, even as we speculate, the questions remain unanswered. Could life have started earlier than we thought? Are there ancient galaxies where the first sparks of life have already come and gone? Or are we witnessing the very beginning of something that will take billions of years to unfold? These are questions without immediate answers. They are gentle questions, meant to be pondered slowly, without urgency. They remind us that the universe is vast, that time is immense, and that the story of life may be far older and more widespread than we can imagine. As we drift through the cosmos in thought, we realize that these silent questions are part of the universe's rhythm. Life may be rare, or it may be everywhere, quietly forming in galaxies we can barely detect. The molecules and water we observe are not only building blocks, they are invitations to imagine possibilities far beyond our reach. And so, we sit with these thoughts, quietly contemplating the potential of life across space and time. We do not rush. We do not demand answers. We simply observe, reflect, and allow the wonder of the universe to settle gently around us. The universe is patient. Its secrets are patient. And in that patience lies a quiet comfort, a reminder that life, wherever it begins, is part of a story far greater than any single planet or single moment. As we drift deeper into the universe, we begin to notice a quiet rhythm. Space itself acts as a vast, gentle laboratory, where chemistry unfolds slowly and patiently, far beyond the noise and haste of life on Earth. Molecules drift through the darkness for billions of years. They move silently, sometimes combining, sometimes separating, slowly forming the ingredients of worlds yet to exist. Hydrogen, carbon, oxygen, nitrogen, they travel across galaxies, floating in clouds of gas and dust, waiting for the right conditions to meet and react. Time in the cosmos does not rush. It moves at its own pace, measured in millions and billions of years. For us, time can feel fleeting, urgent. But in the vastness of space, moments stretch, and change happens gently, imperceptibly, almost like breathing. Consider a single molecule of water drifting through an ancient cloud. It has traveled across the void for billions of years, untouched, unnoticed, yet it carries the potential for life. Perhaps it will become part of a planet, an ocean, or even a living cell one day. Its journey is slow, but purposeful in its own cosmic way. The chemistry of the universe is not dramatic. There are no sudden explosions, no urgent messages. It is a slow, deliberate unfolding, a quiet process that eventually leads to creation. And it is everywhere, in every corner of space. In distant galaxies, in clouds near newborn stars, in the debris of supernovae, the same molecules drift and interact in subtle, unseen ways. There is a calmness in this thought. The universe is not chaotic. It is not hurried. Even the most complex molecules emerge from simple beginnings, patiently following the rules of physics and chemistry over unimaginable spans of time. As we observe this quiet chemistry, we are reminded of something profound. Life, planets, stars, even galaxies, are not accidents. They are the result of countless small interactions, unfolding in slow motion across space. Every atom, every molecule, is part of a larger rhythm that has been continuing since the earliest moments of the cosmos. This segment of the universe teaches patience. It teaches that change can be slow and steady, and that beauty often exists in subtlety. The molecules that float through space are like whispers of the universe itself, quiet, gentle, and full of potential. And so, as we drift among these ancient clouds, we allow ourselves to settle into the same rhythm. Breathing slowly, observing quietly, letting the calm of the cosmos fill our minds. Time stretches. Space expands. And the chemistry of the universe continues its gentle work, shaping everything to come. In this quiet laboratory, we are reminded that creation does not need urgency. It needs patience. It needs time. And it is happening all around us, silently, calmly, and beautifully. The universe is alive in the most subtle way. Its chemistry drifts through space like a slow, endless river. And as we move with it, we feel a profound sense of peace, a sense that the cosmos, in all its complexity, is quietly unfolding exactly as it should. As we approach the end of our journey through the cosmos, it is worth pausing to reflect on what we have witnessed. The James Webb Space Telescope has shown us galaxies from the earliest moments of the universe. It has revealed molecules, water, and the quiet chemistry that set the stage for life itself. In a sense, JWST acts as a mirror. A mirror not just into space, but into our own origins. The light it captures, traveling billions of years to reach us, carries the story of the universe's past. And that story is, in part, our story as well. Everything on Earth, the air we breathe, the oceans, the mountains, and the life that surrounds us, was formed from the material produced by stars. Carbon, oxygen, nitrogen, hydrogen, these elements were forged in the hearts of distant stars and spread across the cosmos through their quiet cycles of birth and death. It is a gentle and humbling thought. The same molecules drifting through galaxies billions of years ago now exist inside us. Every atom in our bodies has traveled across time and space, part of a universe that has been quietly preparing for life from the very beginning. As we consider this, let us take a slow, calming breath. Let the vastness of space fill your mind, and allow yourself to feel the deep connection between ourselves and the cosmos. The universe is not separate from us. We are part of its story, and it is part of ours. And now, as the light of distant galaxies fades from our view, let the mind settle into silence. Imagine the stars continuing their quiet work, the molecules drifting, and the universe slowly unfolding, just as it has for billions of years. There is no rush. There is no urgency. Only the gentle, ongoing rhythm of creation. Everything we are, everything we see, has emerged from this calm, patient process. And as we fade into darkness, let this final thought linger softly. The universe is quiet, but it is full of beginnings. Thank you for joining us on this journey through time, space, and the quiet origins of life. If you enjoyed this experience, consider subscribing, liking, and sharing. Every small action helps us continue exploring the universe together.